All right, welcome back to the last video for chapter 3, section 5. We are going to find the distance from a point to a line. Now, I got out my graphing notebook. I don't know, you probably can't tell with this resolution. I got out my graphing notebook for this. Oh, and my shiny forehead. You don't need to necessarily use your graphing notebook, but the idea, the concept, the visualization is pretty important, at least to have in your head as you're doing this. Otherwise, you're not going to be really sure why you're doing this. Okay, so let me go right to my notebook, and I think you can see the fact that it's a graphing book at this point. We are on page 159, by the way. Okay, and I'm going to do actually all the examples, including the extra example that the teacher's edition has, because I think it's that important. And you're going to practice on big ideas, and that's going to be how you show that you can do it. Okay, so let's just start with number 6. We're all looking at it, right? Bottom of the page. Again, the example 5 is very good. Example 5 is probably one of those examples, though, that you're going to want to see a video of. So if you don't particularly like my video, if you want an extra viewpoint, go to the Student Dynamic ebook. I've said it before, it must be important. Watch the video for example 5 so that you get another perspective. All right, we are finding the distance from this point to this line. All right, now, why is this interesting? Why is it important? What the heck is it? Now, for you, you might want to do this, you don't have to, but this is the concept. We have a point at 6, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, here's our point. We have a line at y equals x plus 4. So it has a y-intercept. Let me use another color here. It has a y-intercept of 4. It has a slope of up 1 over 1. All right, and as accurately as possible, I'm going to draw the line. Okay, now here's the idea. We're finding the distance from this point to this line. The shortest distance from a point to a line would be the distance that intersects that line perpendicularly, all right? Perpendicularly. So if I want to find the distance from this point to this line, I better find the closest point to it, to this point that's on this line. Okay, so if I walked straight to the line perpendicularly, where would I end up that's on y equals x plus 4? All right, so if I want to find that point, well, guess what? I can figure out what's the equation of this perpendicular line and then set them equal to each other. So, all right, let's see. I need an equation of a perpendicular line. It's perpendicular, so the slope is going to be perpendicular to, what is it here? 1. All right, so the slope of my perpendicular, remember in the last video I used M for slope, M for mountain. Mountains have slopes. Perpendicular symbol. Now the opposite, so positive becomes negative, and the reciprocal of 1 is 1. Oh, I love these lines. All right, and it goes through this point. So I know that y equals mx plus b. I know that I have a y of 4, a slope of -1, an x of 6, and I need to solve for the y-intercept. Now, we're not really going to use this y-intercept, but we need to get it. It gives us the direction. So 4 equals -6 plus b, add 6 to both sides, and b equals 10. So if I were to extend this line segment, the y-intercept would be 10. So my new line is going to be y equals -1x, negative x, plus 10. And if I want to know where my perpendicular line meets with my original line, I can set those two equal to each other. And also it looks like my document cam froze for a second. So I'm going to set them equal to each other. I have this line, I have the new line we found, and I have this new perpendicular line. Well, guess what, kids? Math makes sense. If y equals that and y equals that, why don't we set those two things equal to each other? If this equals that and the same thing equals something else, these two things have to be equal. Negative x plus 10 equals x plus 4, right? All I did was I took this over there, took that over here. All right, now let's just do one color and I'll solve for x. So we're going to add x to both sides. That way I get a nice positive number. Take away 4 from both sides. That's 0. 10 minus 4 is 6. X plus x is 2x. And divide by 2. X equals 3. Now, that doesn't give us the distance. Oh, I apologize. Let me move down and wait for the document cam to unpause. It doesn't give us the distance. That just gives us the x coordinate of this point. Now, figure not drawn to scale, but it's at 3 something. I'm going to make a giant point since I didn't do a very good drawing because I'm not a robot. But it's at 3 something. Okay, so 3 what? Well, kids, I mean, if I know an x and I have, two beautiful equations that will tell me the y, let's just plug it into one of them. 3 plus 4 is 7. Oh, and let's say you didn't believe me and you picked the other equation. Negative 3 plus 10 is also 7. So the point where these two lines intersect is at 3, 7. Okay, now pause your mind. Take a deep breath in. Let's review real quick. You have the ability to pause the video and rewind, which you're probably going to want to do. We will do 2 more examples though. This will be a longer video. But what did we do? Let's see. We were given a point and a line. We did a lot of math right now. Math that you might not be used to doing. Might have been a year or more or less since you've done it. So I graphed it to give you an idea, a visual. Point, line. Okay. The directions say, and I'm going to look back at my book, just to be clear, find the distance from this point to this line, which means we want the shortest distance, which means we want to make a perpendicular line. So we have to make a perpendicular line. Well, we know how to do that. We have to find the perpendicular slope. We then plug in the point and the new slope into the equation, and we get that. Now, something that you probably did very fast in Algebra 1, or maybe it wasn't very clear because you were younger, but now you're older and you're wiser. If you want to find out where two lines intersect, just set them equal to each other. We both have y here, so set the two lines equal to each other, but that only gets us the x coordinate, which was 3. But math makes sense. If you have an x coordinate and you have an equation that relates x and y, you can plug the 3 in for x and get your y. So the point is 3, 7. So the point where we start at this point and go towards the line in the shortest distance possible, the point we intersect the line at is 3, 7. Now we can find the distance. Okay, so now we're going to go ahead. We're going to take the 2 points and find the distance. If we remember our old friend, the distance formula, the distance between any 2 points is the difference of the x's squared plus the difference of the y's squared. I really don't like the math formula. I like the English version of it. The distance between any 2 points is the difference of the x's squared plus the difference of the y's squared. Let's remember that here's 1 point, here's the other. Okay. All right, let's take the difference. Actually, you know what? Let's set it up nice and organized. Big square root, big parentheses squared, big parentheses squared. All right, difference of the x's, 6 minus 3. Difference of the y's, 4 minus 7. Okay, 6 minus 3 is 3, 3 squared is 9. 4 minus 7 is -3. -3 squared is 9. So now my distance is the square root of 18. Now, you are in geometry, and you know, if you were walking somewhere or someone asked you, hey, what's the distance from here to there? You're not going to tell them the square root of 18. You're going to sound ridiculous. So let's get our calculators out. Let's type in the square root of 18. Let's round to the nearest 10. So let's say if we're talking about feet, we're not going to say the square root of 18 feet away. We're going to say it's about 4 point. We should put about 4.2. Now there were no units, so we're just going to leave it as 4.2. Actually, we should write down 4.2 units. Okay. All right. A lot of math. Let's see if it makes sense the second time around. It might be fuzzy right now still. That's normal. I'm going to turn the page. Since I was writing in pen, yeah, I don't want to have it bleed through from the other side. So let's do number 7 at the bottom of the page together. All right. Again, this is going to be a long video. It's all right. It's going to be longer when you need to stop and rewind. -1, we want to find the distance from this point, -1, 6, to this line. All right. Again, let's get an idea of what we're doing, right? We are at a point. We see the line we want to go towards. Well, we want to draw it. See, I don't draw accurately. I'm not a human. I'm not a robot. -1 and then comma 6. 1, 2, 3, 4, 5, 6. Boom. Here is our point. We are standing here. We want to get to this line as quick as possible. You can make up your own story. All right, y-intercept is 0. We go down 2 over 1, which means I can, or sorry, down 2, right 1, which means I can go up 2, left 1, up 2, left 1. Notice that I'm trying to go in the direction of my point. Okay, and I'm looking for, here's an approximation, but the distance, the shortest distance to this line from a point would be a perpendicular line to that line. Perpendicular line. That means my slope, my new slope, is going to be the opposite, so positive, not 2 over 1, but 1 over 2. I have an x, I have a y. So let's go ahead and make a new equation. Y equals mx plus b. Notice, by the way, whenever I'm making a new equation, I always write the generic formula out. All right, new y, 6, equals new slope, 1/2. New x, -1, plus b. Oh no, there's a fraction. Haha, kidding, you're not afraid. 6 equals -1/2 plus b. All right, now a couple things. We're gonna obviously add a half to both sides. Now, in our normal equation, it's actually okay to leave it as 6.5 because, you know, it's something we humans can deal with. We can go up 6 and over a half, or up 6 and a little bit more. But we can't do math with mixed numbers. You have to make it an improper fraction. So 2 times 6 is 12 plus 1 is 13. 13 over 2 equals b. So your new equation is y equals the new slope x plus the new y-intercept. All right. Okay, so that's the equation of this line. We already know the equation of this line. And if we want to find out where the two lines intersect, okay, so keep in mind, it's a line that goes off to infinity, and it's 6.5 is right here. So I didn't do a bad job with my guessing and drawing, but we're going to set these two lines equal to each other. So -2x equals 1/2 x plus 13 over 2. Boy, I'm not saying things right now. All right, we just need to get the x's to the other side. So we're going to add a 1/2 x to both sides. We're going to stop and we're going to think. If you are down $2 in Vegas and then you win 50 cents, you walk away from the slot machine down 1.5. That's 3 over 2. 3 over 2, right? -2 plus 1/2 is down 1.5. 2 times 1 is 2, plus 1 is 3, minus 3 over 2x equals 13 over 2. Ooh, wow, stop. I could rewind, or sorry, I could do this all over again. What did I do wrong, kids? Something's not right. Good thing I write out my work so I can check it as I go along. I'm not supposed to add a half. Yeesh. I'm supposed to subtract. Boy, teachers make mistakes. What? So you're down $2 in Vegas, and then you're down another 50 cents. Good job for you by playing the quarter slots after you're 21. Down $2, down another 50 cents. You're down 5 over 2. You're down 5 over 2. Or down 2.5. 2 times 2 is 4, plus 1 is 5. All right. So now we are going to do one of two things. I'm going to do the thing you probably were taught, but there is an easier way to solve this, but it's fine. We're going to multiply by the reciprocal. The reciprocal, not the opposite reciprocal. Negative times a negative is a positive. 2 over 2, 5 over 5. All of that is equal to positive 1. Negative times a positive is a negative. 2 over 2 cancels out, and 13 over 5 is our x coordinate. Are you scared? You shouldn't be. We have calculators to help us do the math. Now this found us the x coordinate where they intersect. So that's about -2 and 3/5. -2 and a little bit more. Now I know I'm going by my bad drawing, but it seems to be working out. -2 and 3/5, right? 5 goes into 13 2 times, 3/5 is 5. -2 and 3/5. All right. What do we do to find the y coordinate that goes with this point? We plug it into one of the equations. What equation do you want to use? Do you want to use the equation that has this, or do you want to use the equation that has less? Both of them are going to get the same answer because math makes sense. I'm going to use the equation that has less. Y equals -2 times -13 over 5. A negative times a negative is a positive. 2 and 5 have nothing in common, so we have positive 26 over 5, which is about 5 and a fifth, right? 5 goes into 26 5 times, and there's a little bit more. And yeah, sure, okay, maybe I'm right. I don't know. All right, so that's that point. And now the distance formula. The square root of the difference of the x's plus the difference of the y's. Remember, our other point is -1/6. And I know that your shields are up because of the fractions. You have a calculator. I kept mine out. So we're finding the distance from this point to this point, because this point is the point on the line that's closest to the point that we started at. So I'm setting up my equation by putting in my blank parentheses nice and big, plus my blank parentheses nice and big, all under a square root sign. And let's say, all right, the difference of the x's. So -1 minus, watch closely, minus -13 over 5. 6 minus 26 over 5. All right, listen, kids. Calculator time. Use Desmos if you need to. You can do it step by step. You can do it all at once. I'm going to do it step by step for you. -1 plus 13 over 5. Enter. Square. Enter. Six. Take away 26 over 5. Square it. We got to square root the whole thing. So 2.56 plus 0.64. Square root answer. About 1.8, right? So comes out to about 1.8 units. Now, if you have a graphing calculator, if you're doing it on Desmos, let me show you. because you don't want to make a mistake. Square root. I need an extra set of parentheses. -1 plus 13 over 5. Close those parentheses, square. Plus, I need a set of parentheses for my y's. 6 minus 26 over 5. Close the y parentheses, squared. Close the whole square root thing. Boom. It does it right there as long as you're organized. Try that on Desmond's. Might be a little bit better because the graphics are better than my TI-83 Plus calculator. Okay. All right. Let's take stock of what we did before we go on to one last thing. I know this is a long video, but that's okay. It just means you have more time to practice and process. We had a point and a line. We wanted to find the distance, which means the shortest distance from the point to the line, which means we need to find the line of that's perpendicular to this line that goes through that point. Perpendicular slope, opposite reciprocal. Plug in the information, x and y and m, to a new equation. Get your new y-intercept. They had fractions. We're not scared. We're just going to be careful. We have a new equation, y equals mx plus b. We have an old equation, y equals mx plus b. We set them equal to each other. We check our work as we go along because even our teacher makes mistakes sometimes, but he fixes them. And we get a new x coordinate. We have that new x coordinate for the point on the line that is closest to the point where we started from which we started. Let's not end sentences and prepositions here. So we have that x. How do you find that y? We plug it into an equation. You pick your favorite equation. This one or that one. I picked that one. So there you go. You get 26 over 5. Now we have the point on the line that's closest to the point from which we started. So we go ahead and we plug it into the distance formula. We do it nice and carefully. You choose your best method. Do you want to do the calculator all at once? Do you want to do the calculator little by little? You still let the calculator do the hard math for you, and you end up square rooting it, rounding to the nearest tenth, and writing the units afterwards. Okay? All right. One last one. Thank you for hanging with me. It's that important. It wouldn't take this long if it was easy. Okay. Now this one is just in the book. Since this is a continuation of 3.5, and I was just recently, as you can tell by my shirt, doing your previous videos, we did an alpha, we did a beta, so we're up to the Greek letter gamma. It is a fish that's diving. We are going to find the distance from this point to this line. Now, you know what? Let's try to be geometry students here, not Algebra 1 students. Can we do it without graphing? So what's the first thing we did? Can you think of it before I tell you? What's the first thing that we did? We had to figure out the perpendicular slope. So the slope of a perpendicular line is opposite reciprocal. Write that down. If you're not used to writing your steps down, write your steps down. First, find the slope of the perpendicular line. It's okay to pause and then continue the video. Now we're going to write a new equation. Here's my new y. Here's my new m. Here's my new x, and we're solving for a new y-intercept. -1/2 times 6 is -3. We're going to add 3 to both sides. There you go. All right, but that's not an equation. We got to do y equals -1/2 x plus 1. All right. So I have an equation of the line. I have an equation for the line that's going to get me from this point to this line as fast as possible. Let me set them equal to each other. We're going to add 1/2 x to both sides. We're going to add 4 to both sides. 2 plus 1/2 is 2.5, which is 5 over 2. Remember, you can't use mixed numbers. That's a 0. That's a 0. 1 plus 4 is 5. We've got to solve for x. We got to multiply by just the reciprocal. 2 and 2 cancels out. 5 and 5 cancels out. We're left with positive 1x on that side. 5 and 5 cancels out. X equals 2. All right, so I now know the x coordinate of the point where I'm going to end up at on the original line. So you can pick either equation. Do you want to pick this equation or that equation to find your y? I'm going to pick this equation. 2 times 2 is 4. 4 minus 4 is 0. So it looks like I end up at 2, 0. So I started here. I ended up here. What's the distance? It's the difference of the x's plus the difference of the y's. Let me copy down my old point. All right. It's the difference of the x's. 6 minus 2 is 4. It's the difference of the y's. Negative 2 minus 0. 6 minus 2 is 4. 4 squared is 16. Negative 2 minus 0 is negative 2. Negative 2 squared is 4. Oh, and we get the square root of 20. Square root of 20 is not something you're going to tell someone for a distance. Plug it into a calculator, and we get about 4.5 units. All right. You just need to soak it in. I highly recommend that you have the steps written down in words to get here. You're probably going to need to go back and watch this video at some point so that you feel confident. It's not that it's difficult, it's complex. It is definitely not easy because it's complex. But can you do every step if you know what you're doing at which point? If you have a direction, yes, you can. All right, that's it. There's no questions to answer. You will have some big idea stuff to do. Take a deep breath in, let it go. Tell yourself you can do this.